In this video, I will show how to use the limit comparison test to determine whether the given series converges or diverges. In our case, we're going to compare the series, the original series, with 1 over square root of n. Now, in order for us to establish this comparison, we have to make sure that the limit as n goes to infinity of the ratio of the general terms of the two series is equal to some constant which is not infinity or 0. As n goes to infinity, the expression that we have is actually approaching to 0 over 0. So we have 0 over 0, and therefore we are going to use the L'Hopital's rule. And to use the L'Hopital's rule, I'm going to replace n with x, and I'm going to differentiate the numerator and the denominator. So the derivative of the numerator is 3 to the power 1 over square root of x times ln 3 times derivative of 1 over square root of x minus derivative of 1, which is 0. The derivative of the denominator is just derivative of 1 over square root of x. As you can see, the derivative of 1 over square root of x cancels, and the only thing we have left is 3 to the power 1 over x times ln 3. As x goes to infinity, we have 3 to the power 0, which is 1, so this entire limit is ln 3, which is definitely less than infinity and greater than 0. Therefore, these two series behave alike, but the one that we are comparing it against actually diverges because it's p series with p equals 1/2, which is less than 1. Therefore, the original series diverges, and the reason is by the limit comparison test.